on this platform for discussing in motion automatic railway bridge. As we are all aware, the transaction of goods take place through these railway bridges, and we used to weigh the weight of the bogie, and through which the net weight of the commodity carrying this weight is being taken out through these in motion roadway bridges, in motion railway bridges, which are very important for any economy, as large number of transactions takes place through these railway bridges. As we are all aware, since last many years we have seen that many times there are a lot of complaints of these fraudulent practices happening at these railway bridges. That's why we thought that under these programs, our Azadi Ka Amrit Mahotsav, we should have one lecture on these in motion railway bridges. We have with us our beloved Joint Secretary Sir Shri Vineet Mathur Sahab, who is himself an engineer from IIT and having a lot of management experience, international exposure, and being the government service as an international postal service officer and a joint secretary in our department. He is always very good to work with us, and I certainly I feel during the COVID time he helped us a lot for issuing the advisories and the notifications in the interest of industries and the consumers. Sir, thank you very much for your kind support, for which you will be always known in the history of the legal metrology, that you have supported us wherever we requested, and you have always showed your blessings, given us your blessings for the development of this legal metrology. Sir, I would like to request you to kindly inaugurate this conference, please.
Yeah, thank you very much, Ashutosh, and good morning to all participants in today's very important session and conference on in-motion railway weighbridges. And railways has been the backbone since maybe the British times, and they are carrying the most large quantities of commodities across the country. If you remember the history of India, it was always said the Great Bengal Famine occurred because there were no rail coaches available, and maybe the commodity and the produce for food was not able to be transported to Bengal from other parts of the country, and some of them were taken out of Bengal, which resulted in the Great Indian Famine in early 1900. So railways has been an extremely important segment of the society. It is the economic backbone and infrastructure of the country, and the commodities and goods which are transported through our goods trains across the country, and otherwise also the passenger and the express trains also carry certain goods and services which are of express nature. It becomes extremely important that the weighments and the weights of items which are sent are calibrated, calculated quantitatively in lines with the latest technology in legal metrology in the world. So I am aware there are a lot of modernization which has happened in the last so many 20, 30 years. The entire in-motion railway weighbridge system has been overhauled, and there's a lot of more modern technology which is coming into this particular segment. Indian systems and maybe Indian industry which is supporting the in-road railway weighbridge systems, they should keep in track with whatever are the latest technologies, and maybe bring in into our railway system payment system. So I think this particular session is extremely important. We have the best of the experts who are working in this area. There are international guidelines also available. There are people who are writing in this particular subject. They have research submissions across the world, and I think if we join hands and brains with all the people, we'll be able to have the best weighment measurement systems for these things. As you already know, the largest infrastructure movement is done through railways. There is a lot of modernization which has done in the container systems. So there are a lot of container systems also which have come in the world, and large part of goods movements and services are now being done through container movement. And Container Corporation of India is a big subsidiary of the Indian Railways. which is supporting the container movement. Besides this, there is a lot of container movement which is also done through the road transport mechanism across the world. So together, the Weighment in motion Weighment systems, whether this is for railways or for other transport systems, it's an interesting dynamic engineering area, and we need to have it right in the country. We need to bring the latest technology here. I wish to listen to the best experts who have been brought in. They are the people from the industry and from our government organizations who are working in this area. We have a support college in IILM Ranchi, where there's a lot of research work done in all these areas also. It will be very nice to listen to them. And I wish everyone a very success. Whatever are the new, let's say, points which emerge out of today's conference, we in the government would be wanting to look into them and wish to probably do another stakeholder analysis and take them forward so that the best technology and the latest from the world is received here. With these words, I thank Agarwalji and I wish today's deliberations a lot of success. Dhanyavad.
Thank you very much, sir. Thank you for your kind words. Sir, today we have with us our one of the great professor, Dr. D.K. Trivedi. He is known in the field from Indian Institute of Legal Metrology, Ranchi. And he has a lot of teaching experience, a lot of R&D experience, a lot of research papers. So I have requested him. And the second, my great friend, Mr. H.K. Vesh, who is from Every India Private Limited. Actually, sir, in India, the weighing and measuring culture, the weighing and measuring structure, the weighing and measuring technology was brought by Every India Private Limited. Actually, it's a British company, and earlier they started, and it is in Vallabhgarh, Faridabad. So we have very good friends. If in India any of the manufacturer is manufacturing his own weighing and measuring instruments, he must be either from Every India, either his dealer or his repairer or something. He has started his career from Every India. 90% I have seen they are from Every India. So we have with us, and sir, it will be unfortunately, sir, I could not show you. They have very good railway facility. Even they have in their own campus. There is one wagon, there is one engine, and this whole facility they have in every Faridabad. Sir, if you will be having at any point of time a small hours, we can visit our RSN Faridabad as well as their facility. You will see that how best
हाँ
these people are
जी
doing in India. Sir,
मेरा
then
रिक्वेस्ट है कि यदि आप
we have
चाहें
with
तो
us.
हाँ मैं थोड़ा बोल दूं सर।
सर हमारे साथ डायरेक्टर साहब है दीक्षित साहब। मैं रिक्वेस्ट करूंगा कि दीक्षित साहब अपने दो शब्द प्लीज कह के इस कॉन्फ्रेंस को स्टार्ट करें, प्लीज दीक्षित सर।
पहली बात तो आपको बहुत बहुत धन्यवाद जो है कि आप रेल इन मोशंस के बारे में ये सब्जेक्ट रखा जो है, जो कि एक बर्निंग टॉपिक है। और ये बर्निंग टॉपिक जो है अभी भी हमारे देश में जहाँ भी इन मोशन वे ब्रिजेस की चर्चा होती है, पर्टिकुलरली रेल में, वहाँ पर ये एक बहुत कॉम्प्लिकेटेड सब्जेक्ट माना जाता है। इवन दो हमारे पास तमाम तरह की वेइंग इंस्ट्रूमेंट आ गए हैं, है कि जो वेइंग मेजरमेंट है वो उन लेवल्स का नहीं हो पा रहा है जिसके कि हम लोग कल्पना करते हैं। जो है इसका बहुत सा बिंदुवार कारण है कि हमारी टेक्नोलॉजी, स्पीड ऑफ द ट्रेन्स एंड सो मेनी अदर टाइप ऑफ थिंग्स है। तो हमारा जो पहला ऑब्जर्वेशन है वो ये है कि जिन क्षेत्रों को मेजरमेंट करना चाहिए उनको स्टैंडर्ड वेट से पहले कैलिब्रेट करना चाहिए। जब तक आप उनको स्टैंडर्ड वेट से आप कैलिब्रेट नहीं करेंगे तब तक जो है उनके भीतर जो माइनर एरर जो है बार बार रिफ्लेक्ट होती है, रिफ्लेक्ट होके क्यूमुलेटिव एरर्स के रूप में वो जनरेट करती है, वो जनरेट करती स्टेशनरी वेट्स होने चाहिए, जो स्टेशनरी वे ब्रिजेस होने चाहिए, जिससे कि जो ऑनलाइन वैगन वेट्स हैं उनको जो है कैलिब्रेट किया जा सके। तो ऑन ये जो वैगन वेट्स हैं, वैगन वेट्स में आप ये नहीं कह सकते हैं कि उसमें कोई मटेरियल रख दिया तो उससे वो वैगन वेट बन जाते हैं। हर वैगन वेट में आपको स्टैंडर्ड वेट रखना पड़ेगा, और ये नहीं है कि आप 20-20 केजी के वेट को ऐड करते जाएं। यदि आप 20-20 केजी के वेट को ऐड करते जाएंगे तो उनका क्यूमुलेटिव एरर्स जो है बहुत ज्यादा होता जाएगा। इसलिए उसमें 1 टन या 5 टन जिस तरह के भी एक्यूरेसी के वेट हैं, जो है हाई डिनोमिनेशन के वेट हैं, उनको रख के जो है वैगन वेट्स का निर्माण करना चाहिए। तो यदि एक रेल में 5 वैगन वेट्स लगाए जाते हैं तो उन्हें चिन्हित मात्रा में किया जाना चाहिए। नहीं तो 10 वैगन वैगन वेट्स हैं तो आप 10 को लगा सकते हैं, और इंजन के तमाम चीजों को आप स्टेशनरी वेइंग एंड मेजरमेंट वे ब्रिज के माध्यम से उनकी जानकारी कर सकते हैं, और एक पर्टिकुलर लो स्पीड पर आप जो है इनकी गणना करके वे ब्रिज का जो है तुलनात्मक अध्ययन आप कर सकते हैं। तो आई थिंक जो हमारे अनुभव में आया है वो उसमें 2 तरह की चीजें हैं। पहला तो ये है कि जो वेइंग रेंज होता है उसका जो है पूरा कैलिब्रेशन होना चाहिए विद द स्टैंडर्ड वेट्स, जो है जो कि हम लोग जो है नहीं किया करते हैं।
हम लोग एक्सपर्ट्स को सुन लेते हैं।
Yes, sir.
वैगन वेट्स में या उससे अधिक क्वालिटी के वेट्स को उसमें रखना चाहिए, जिससे कि उसके एरर्स को कम से कम किया जा सके। उसके बाद जो है ट्रेन की एक्यूरेसी को चेक करना चाहिए जो है। तो इस तरह से हमारा जो अपना एक फील्ड है मेट्रोलॉजिकल कैरेक्टरिस्टिक को जानने का, उस तरह से उसका जो है फील्ड में ये चीजें निर्धारित की जा सकती हैं। वैसे तो मॉडल अप्रूवल में जब आप जाएंगे तो उसके इंडिकेटर्स का तमाम तरह से इलेक्ट्रॉनिक परीक्षण करेंगे, और स्पैन स्टेबिलिटी टेस्ट करेंगे, और भी जितने भी टेस्ट हैं वो सब करेंगे जो है। तो बस
I think, sir, कुछ disconnect हो रहा है.
आवाज कट रही है।
So we can
वो
start, I think, with the expert now.
वो बहुत ही आवश्यक चीजें हैं, और उनके अनुसार जो है हमें आगे बढ़ना चाहिए। बहुत बहुत धन्यवाद जो है।
Thank you very much, sir. Thank you, sir. आपकी आवाज बीच में काफी ब्रेक हो रही है. Kindly check your signal. Thank you very much, sir. Sir, we have with us Dr. D.K. Dwivedi. Dwivedi sir, kindly share your screen and start your, just enlighten us how this type of technology works in the country, please.
नहीं, मेरे सिग्नल में कोई दिक्कत तो नहीं आया बोलते वक्त?
सर बीच में ब्रेक हो रहा था आवाज आपका कई बार,
जैसे
बीच में कट जाता है ना काफी देर।
नहीं, तो मैंने तो 3-4 पॉइंट को बताने का कोशिश किया हूँ। आई
ठीक है
थिंक
सर।
उनको समझ गए होंगे
जी
कि
सर।
जैसे वेइंग रेंज में जो कुछ भी एरर्स हैं उसको
जी
इनिशियल स्टैंडर्ड वेट से जो है आप कैलकुलेट कर लीजिए।
जी
बगल में एक जो है स्टेशनरी वेब्रिज होना चाहिए,
जी
और जो वैगन वेट्स हैं वो जो है स्टैंडर्ड 5 टन की एक्यूरेसी के हिसाब से बनाए जाने चाहिए, जिससे कि उसमें एरर्स जो है कम से कम हो। तो इसके हिसाब से आप जो है इन मोशन वे ब्रिज में, इन मोशन रोल रेलवे ब्रिज में आप जो है एक्यूरेसी टेस्ट, रिपीटेबिलिटी टेस्ट, अन्य तरह की जो टेस्टिंग होती है, या कार्नर लोड टेस्ट है, या अन्य तरह की जो टेस्टिंग होती है, उसको आप जो है कर सकते हैं जो है।
ठीक है,
तो
थैंक यू वेरी मच सर, थैंक यू।
मेरा
द्विवेदी साहब
मेरा
प्लीज
जो
शेयर योर स्क्रीन।
हाँ, तो जो मेरा इनपुट रहा है वो जो है बहुत सेंसिटिव रहा है, जो कि लोग नहीं किया करते हैं। इस
सर आप ये आप एक्चुअली में ऐसा करना, जब एक बार ये हो जाएगा ना, तब ये पॉइंट देंगे तो शायद ज्यादा लोगों
ऊपर
की
क्या,
समझ में आएगा कि क्या करना चाहिए।
हाँ, क्या करना चाहिए।
वो
नहीं
बाद
तो
में।
टेस्ट करने के तो बहुत से तरीके होते हैं।
जी जी सर, थैंक यू।
हम्म।
द्विवेदी साहब प्लीज शेयर योर स्क्रीन। द्विवेदी साहब आपकी आवाज नहीं आ रही है, आपका माइक ऑफ है।
Agarwal sir, can you hear me?
ये सर आपकी आवाज आ रही है, द्विवेदी साहब की
Okay,
आवाज नहीं आ
I'll
रही है।
transfer the seat.
जी, कुणाल साहब आपकी आवाज आ रही है, द्विवेदी साहब की आवाज नहीं आ रही है। द्विवेदी साहब आपकी आवाज नहीं आ रही है, माइक ऑन कीजिए। अदरवाइज अदरवाइज आप कुणाल साहब के उससे कर लीजिए, सेट से।
He is taking my seat. Is coming. Just 1 minute, please. Hello.
हाँ आ रही है आवाज। द्विवेदी साहब अपना कैमरा भी ऑन कर लीजिए और स्क्रीन शेयर कर लीजिए प्लीज। संतोष जी ये अभी कुणाल साहब के उसमें सिस्टम में दे दीजिए स्क्रीन शेयर का राइट।
Permitted, sir. Permitted, sir.
थैंक यू वेरी मच, थैंक यू।
Hello.
जी द्विवेदी जी बोलिए।
Okay. Very good morning to all. Respected Gun Secretary sir, all panelists and the participants. Today is the very important topic, automatic railway bridge. If we see legal methodology system at a glance in India, then we will see 4 things are there: weight, measure, weighing instrument,
थोड़ा
measuring,
द्विवेदी जी थोड़ा आगे करके बोलेंगे, थोड़ा माइक के आगे आगे।
weighing instrument, measuring instrument. Weighing instrument in our legal methodology general rule 2011 under the schedule 7 heading A, B, C, D, E, F, number of headings are there, and broadly speaking, weighing instruments are divided in 2 parts: non-automatic weighing instrument and automatic weighing instrument. Non-automatic means during the weighing process, no intervention of operator. Automatic, during the weighing process, automatic means during the weighing process, no intervention of operator, and in non-automatic weighing instrument, there is an intervention of operator. Automatic railway bridge, one of the kind of the automatic weighing instrument. Whether it is non-automatic or it is automatic, in both cases, the principle is action of gravity. When I will come on the automatic railway bridge, for the purpose of the enforcement in a states, if we see metrological control is divided in 2 parts. One is for weights, measures, weighing and measuring instruments, and another is for package commodity. When I'm talking about the weights, measure, weighing and measuring instruments, then further we see metrological control in two parts. One is with the central government and another is with the state government. When I'm talking about the weights, measure, weighing and measuring instrument, for which model approval is required, central government issue the model approval based on the request, testing and other things. Once the certificate is issued, state government issue the license to the manufacturer. And on the issuing of the license, manufacturer starts manufacturing. And then state government to the initial verification, subsequent verification and inspection. All those things come under the metrological control. When we are talking about the verification, then definitely as a LMO, as a legal metrology officer, we should know the detailed process of the verification. I will try my lecture step-wise process from where we have to start the verification. So let me share. Automatic railway bridge. Under this discussion, I will cover a simple introduction, because if we are not familiar with the instrument, we can't do the justification with this. General terminology we should know. Accuracy class and MP. This is the metrological requirement of any instrument. Then verification and observation, if the time will permit me, then I will come step by step so that any LMO, how they have to start without any confusion and do the enforcement in an effective way in the field. Automatic railway bridge, because India is the member states of OIML, then it is the OIML recommendation 106, from where these technical things are taken, and it is in our general rule under heading C, 7 schedule, legal metrology general rule 2011. Before discussing the automatic railway bridge, I would like to show few pictures so that we can have the idea about the terminology and about the testing. This is a railway track. There is a load cell. Load cell is the core part of the whether non-automatic weighing instrument or automatic weighing instrument. Very simple. It transfers one form of energy into another form. When the load comes here the strain gauges are there in a balanced condition, which is stone bridge. But when the load comes, then it gives the signal. These signals are very big, that are amplified by using analog to digital converter, converted into the digital signal, and we are getting the output in the form of the display or in the form of the printing. When there is no load, no signal. More load, more signal, means it follows the linearity of the load cell. That one decides the weighing range of the instrument. This is the view of the railway bridge, blue part, because there is not a very beautiful building like that. This is an instrument set on a railway track. So please see, the blue part is called the weigh zone, from here to here. This is the weigh zone. And this is the load receptor area, where the load cells are there. Load receptor area. But very important thing I want to discuss here. Based on the load receptor size, railway bridges are in two forms. One is for partial weighing and another is for full draught weighing. Partial weighing means the load receptor size is not quite enough in size to accommodate the wagon. Then by part, axle-wise weighment is made. And that one is called the partial weighing automatic railway bridge. And in the field, 99% partial weighing railway bridges are there. Full track weighing means the size of the load receptors in such a way that at a time entire wagon can be accommodated. When I am talking full track weighing, in this condition, maximum capacity of the instrument is equal to the maximum wagon weight. So this is the weight zone. The area which one is neither the part of load receptor nor load receptor, this is called the apron. From here to here called apron. From here to here is called apron. There is also concept of track switches. Why? Because there is also maybe engine, maybe guard vehicle, speed, so many things are there, technical part. These track switches identify whether this is an engine or this is a wagon for which instrument is designed. Because in railway department, so many types of the wagons are there. But all wagons are not suitable for women. So these track switches identify whether the payment has to be made or payment has to not be made. If the speed is more than the prescribed maximum speed, then further the error will be there. So track switches may be contact and may be non-contact. If contact, then these touches the axle and give the sense of the speed and give the nature of the wagon. And these are non-contact based on the laser system, etc. After that, there is a microcontroller. Once the signals are generated from the load cell just like as a transducer, that signals are amplified. That signals are converted from analog to digital, and finally that signals comes to the microcontroller where the pre-programmings are there. Being the automatic railway bridge, there is a most important role of the programming. This one is the microcontroller. Wagon. Now, next is general terminology. I will not give more time on general terminology. Just I will introduce only few things. Then I will come directly on the testing process. General terminology means what? The things associated with that instrument comes under the metrological characteristics, metrological requirements, and metrological control. Under general terminology, 4 or 5 things I would like to give the focus on that. Number 1, very important in the field, I have found that under the declaration part, means marking part, so many mistakes may be made by the manufacturer or user because of lack of awareness. Just I would like to share that. What thing? One thing is maximum capacity of the railway bridge and maximum wagon weight. Sometimes you find under the mandatory marking, because in our rule it is given, markings are there. Because without marking, we can't identify what kind of the instrument is this. For example, electronic balance. The legal name is non-automatic weighing instrument. But on the instrument, non-automatic weighing instrument is not written. Gravimetric filling machine. Gravimetric filling machine is not written. Railway bridge. This is not written. But as a LMO, how can I identify whether this is a standard weight or measure or not? Whether we have to verify or not. That one is the only tool from the markings. What marking? Just I am giving one example. It is written in any railway bridge. Maximum capacity 100 ton. Please listen me. Maximum capacity 100 ton and maximum wagon weight 100 ton. This is written. Our LMO goes and read maximum capacity 100 ton, maximum wagon weight 100 ton, and number of partial weighing 4. Then we have to check whether it is correct or not. Then we will ask to the user, okay, you have written maximum capacity 100 ton, you have written maximum wagon weight 100 ton, you have written number of partial weighing 4, kindly tell me at a time maximum wagon of what load passing over the load receptor. Answer will be 100 ton. then you say 100 ton. Number of partial weighing 4, that means at a time 1 axle will come. That means at a time 25 ton will come. Then next axle will come, then next will come, then the totalized will be 100 ton. Then answer is maximum capacity is 25 ton, not 100 ton. Maximum wagon weight is 100 ton. Because 4 axles are there, so at 1 axle, 25 ton will come at a time. If the number of partial weighing 2 is written, that means wagon has 2 axles. And maximum wagon weight, if 100 ton, then at a time 50 ton will come. That means maximum capacity is 50 ton, because in railway bridge it is written maximum capacity without totalization. So this is the difference between maximum capacity and maximum wagon weight. Second thing, before starting the verification, we have to see what minimum capacity shall not be less than 1 ton in any case. Minimum capacity of the railway bridge shall not less than 1 ton. Then what about maximum side? Maximum value of minimum capacity shall not be minimum wagon weight divided by number of partial weight. Then what is a minimum wagon weight? Minimum wagon weight shall not less than 50 D. D means scale interval. For example, scale interval is 0.2 ton. Then 50 into 0.2, that means 10 ton. And number of partial weighing is 2. So 10 by 2 means 5 ton. That means for this railway bridge, minimum capacity shall not less than 1 ton and shall not be more than 5 ton. All those things we have to check. Then we have to check accuracy class, whether it is correct or not. If the sir will permit, then directly I will come on the testing process. Step involved in verification of automatic railway bridge based on Legal Metrology General Rule 2011 and OIML R 106. How many steps involved? Step 1, just Elmo reach to the railway bridge. That one is due for verification, means under verification. Then what first work should be there? Marking given on the instrument shall comply. Marking on instrument, first off we have to check. Not only check, not only read, but we have to cross check. For example, accuracy class is written 0.5. Maybe it is not correct. And if accuracy class is not correct, then maximum permissible error and the process of verification, everything that will be affected. So first of all, marking on the instrument shall comply the requirements. What things? Accuracy class, regard scale interval, maximum wagon weight, minimum capacity, minimum wagon weight, etc. as per the General Rule 2011. Second thing, establish whether the automatic railway bridge is partial weighing or full dart weighing. One thing I would like to discuss in between the verification process, very popular word in automatic weighing instrument. What word is? Control instrument. Control instrument. Sometimes question comes, what is a control instrument? What is the use of that? Nothing. Control instrument is the non-automatic weighing instrument which is used to prepare the reference wagon. Again, I would like to supplement. When I am going through the verification, definition of the verification as per the Act, I found 4 things are there: comparing, checking, testing, adjusting. As a LMO, we can compare only when we have the standard. For example, cast iron weight, we have the standard, working standard weight. Capacity measure, we have the standard. But in railway bridge, we have no prior standard. in our office so that we carry the reference wagon and just start the verification. No, we have no prior standard. We have to prepare standard at that time. We have to prepare our standard in form of the wagon, and that wagon is called reference wagon. If we have to prepare, that means we have to some equipment, some device, that is called the non-automatic weighing instrument. And where the word comes static weighing, because weighing are two types, static weighing or in motion weighing. When the word comes static weighing, means we are talking about the non-automatic weighing instrument. Static means, for example, 1 kg sugar we have to place, we will place here, maybe it is 900 gram. Then we can add or subtract. It is only possible when it is static. Similarly, we have to prepare the reference wagon. Then a non-automatic weighing instrument is required. That is called control instrument. Class 3 or class 4 accuracy. Sometimes what happens, along with the railway bridge itself, control instrument facility is there. But it is not mandatory. But if user wants, then manufacturer give the facility. There is a switch which can change over automatic mode into non-automatic mode. That control instrument is called integral control instrument. Integral means it is integrated with the railway bridge. And if such facility is not available, then we have to use separate control instrument nearby the railway bridge. That control instrument is really non-automatic weighing instrument having the platform in form of the railway track, where we can stand the wagon and we can prepare the wagon of our required value. That value, for example, I have prepared 100-ton wagon. That is a standard. And when I will pass 100 ton, then the railway bridge show 100 ton, either less or more or equal. If less or more, then must be within the maximum permissible error. That means MP is most important thing before starting the verification. If we have no correct maximum permissible error, then we can't do the justification with the instrument. So in second step, we have to see whether it is a partial or it is a full. So visual inspection we can see. If the size of the load receptor is small, that means it is a partial. If the size of the load receptor is quite enough to accommodate the wagon, means full track. Okay. Now step 3. Step 4. This is not only important, okay, we have non-automatic weighing instrument and this is a control instrument and just we will prepare the reference wagon. No, that non-automatic weighing instrument, which one is called control instrument, must pre-verified before preparation of the reference wagon. Just before or prior, whatever the periodical interval, as per the 7 schedule heading A. And very simple, when we are talking about the verification, that means verification standards. Whatever kinds of the verification standard, irrespective of that, one thing is common, that standard approximate 3 times more accurate than that of under verification. Now step 5. If every marking is correct, everything is correct, then what should be the next step? Next step, we have to prepare our standard, because pre-standards are not there in the form of the wagon, then we will prepare the wagon. Before preparing the wagon, question comes, how much wagons we should prepare? 1, 2, 3, or any provision is there. So we have to select the number of reference wagon. I will show the table. There is a table. If the railway bridge is designed for payment of the train having maximum number of wagons 10 or less than 10, then actual number of minimum reference wagon are required. If the railway bridge is designed to weigh the train having the wagons more than 10 and less than or equal to 30, then minimum reference wagon required 10. And if the more than 30, then minimum number of reference wagon required 15. In table, sometimes some confusion creates. I will show that table actually. Just first I would like to show that table. One second, sorry. Okay, during the verification part, I will show the table. But in the table, it is given on the left of that maximum number of wagon in test train. This is written. And other side, it is written minimum number of reference wagon. When the word comes test train, then sense goes to the test train is prepared by the LMO. And when I'm talking about the minimum number of reference wagon selected by the LMO, if both things are selected by the LMO, then what thing is related with the instrument? That question will come. So on the left, the meaning of that, the maximum number of wagons in the train intended for payment by the railway bridge. Railway bridge is not designed for infinite number of wagons. If it is written, railway bridge is designed for 60 wagons train. So more than 60 wagons, if there will be there, then maybe the result have the excessive error due to the repeatability and heating effect. So if railway bridge is designed for a train not more than 60 wagons, then means number of wagons limited. That is the meaning of that. If the 60 wagon, then minimum number of reference wagon selected by the LMO will be 15, means 15. After the selection of wagon, we will prepare that wagon of the load which covers the weighing range from minimum to maximum capacity of the railway bridge by using control instrument. Once the wagons are prepared, then second thing is required maximum permissible error on that wagon. While when you pass the wagon, then indication will come whether that indication is within limit or not. How one can check? By the maximum permissible error. Sixth step is maximum permissible error calculation. Then MP is ready, then we will perform the in motion test. Because in motion, three types. One is uncoupled, next is coupled, then train weighing. What is the uncoupled? Uncoupled means single wagon comes independently without engine by approach of inclined plane. This is a wagon way. Indication come wagon wide, but single wagon come. It is not coupled with other. It is not coupled with other, called uncoupled way. Coupled means a train comprising 60 wagons. Train is passing with engine and guard bogie, but display come wagon wise. If the 60 wagons are there, then 60 readings will come. This is called coupled wagon weight. If the same train is passing by programming as per the need of the train weighing, if it is given, a train is passing having 60 wagon, but wagon wise display is not there. In the last totalized result come, that one is called the train weighing. So before starting the verification, Elmo will check whether it is designed for wagon weighing or train weighing or both, because a single railway bridge can be used as a wagon weighing as well as for train weighing if the facility is given. Because of that reason, a railway bridge may also have more than one accuracy classes. Because when I will come step by step, then I will discuss the accuracy classes. Railway bridge has 4 accuracy classes: 0.2, 0.5, 1 and 2. 0.2 is the most accurate. Then thereafter 0.5, then 1 and then 2. Sometimes what happens? We found that 2 accuracy classes are given, 0.5 and 1. If the knowledge, if we are not aware, then we may think maybe it is wrong, but not wrong. It is an option in our rule. Railway bridge may have more than 1 accuracy. If 0.5 and 1, then definitely 0.5 is assigned for the train weighing and 1 is assigned for the wagon weighing. That we will check. So directly I come on the with example so that it comes clear. Whatever I have discussed, because I am not would like to give more importance on the general things, just the application part, so that within this short interval we will be familiar that how we have to check. After all those discussion, for example, this is a railway bridge I have taken. Marking accuracy class 2 is given. Scale interval 0.2 is given. Maximum capacity 50 ton is given. Minimum capacity 2 ton is given. Maximum wagon weight 100 ton is given. Minimum wagon weight 10 ton is given. This example you may see. For example, such railway bridge is under verification. We have to verify this railway bridge. How we can start the verification? Please. Keep in mind, accuracy class is 2, the important thing only, and scale interval is 0.2 ton, maximum capacity 50 ton, all those data. Then I am going to start the verification. Step 1, I have discussed, first of all, we have to check the marking. Maybe non-standard marking is there. Accuracy class, we will determine whether it is correct or not. Minimum capacity we will check. Scale interval we will check, and how we will check I am going to discuss. For this purpose, this is the table for accuracy class determination. Accuracy class 0.2, scale interval less than or equal to 50 kg. Maximum wagon weight divided by D, the n value belongs in between 1000 to 5000. Similarly, for 0.5, less than or equal to 100 kg, 1 less than or equal to 200 kg, and for 2 less than or equal to 500 kg, and corresponding n value is there. This table will help us to cross check the accuracy. So let us come on that. Accuracy class is given how much? Accuracy class is 2. The railway bridge under verification. And scale interval is how much? 0.2 ton, means 200 kg. So let us see. We will calculate n value. N, maximum wagon weight divided by D. Maximum wagon weight divided by D. Maximum wagon weight is given 100 ton. D value is given 0.2 ton. 100 by 0.2, it is 500. And D value is 200 kg. So let us see. For accuracy class 2, n value is 500, whether it is correct or not. So for accuracy class 2, n value is 500. And what should be? 100 to 600. That means NY is correct. And what should be the D value? Less than or equal to 500 kg. Our D value is how much? 200 kg. That means DY it is also correct. That means given accuracy class 2 is correct. Second thing, D value is given 200, accuracy class 1, and N is 500. It also comes under the accuracy class 1. So no need to confuse. Manufacturer is free as per the requirement of the purchaser, whether give the accuracy class 1 or 2 or 1 and 2, but not 0.2 and not 0.5 for this declaration. If manufacturer has given 2, that means it follows this table, that means it is okay. So now, as Alamo, I have checked accuracy class is correct. Then next thing, देखिए, thus as per the concern table, it falls in accuracy class 1 and 2. Declared accuracy class is 2, thus accuracy class wise is correct. Next, scale interval confirmation. Whether D value is correct or not, D value always, scale interval always is written in terms of 1 into 10 की power k, or 2 into 10 की power k, or 5 into 10 की power k. K may be positive, K may be negative, or K may be 0. So it is 2, that means okay, 0.2, that means okay, no problem. Then another question, whether minimum capacity is correct or not. You think so many technical things are there. Then the legal proceeding is started whether it is violation or not. But before that, we should be sound with the technical requirement. Next thing, we will check minimum capacity confirmation. I have already discussed minimum capacity not less than 1 ton and not more than minimum wagon weight divided by the number of partial weight. What is the minimum capacity is given in example? Please see. Minimum capacity is given 2 ton and maximum wagon weight, minimum wagon weight is given 10 ton. These data I will utilize here. Please see. Minimum capacity shall not less than 1 ton, not greater than value of the result of minimum wagon weight divided by number of partial weighing. Finally, it comes how much? 5 ton. Maximum is 5 ton. Minimum wagon weight 10 ton divided by 2, 5 ton. And given is 2 ton. So 2 ton is greater than 1 ton and less than or equal to 5 ton. Thus, minimum capacity is also correct. Next, automatic railway bridge under verification, partial weighing, 2 or more parts, same load receptor and the result are automatically added. Means I am saying that it is a partial weighing. Excel wise indication is not there. First Excel pass, second pass, whatever the number of Excel for which the railway bridge is designed. Then in the last, we are getting the wagon weight for wagon weight. Step 4, to use the separate control instrument or control instrument, because we have to prepare the reference wagon. Marking is correct. Now I am going to prepare reference wagon. We will prepare the reference wagon after selection. If the train having 60 wagon, then 15 minimum reference wagon are required. But in the field, it is very difficult, even though to fulfill the minimum requirement, to select the minimum number of reference wagon. In so many places, I found that 2 reference wagon, 1 reference wagon, they are using and verifying. But as per the rule, in no case, not less than 5 reference wagons should be used. Minimum 5 reference wagons are required. Selection of number of reference wagon, I have discussed. I will show the table. This is the table. This is written here. Total number of wagons in a test train. The word test train sometimes gives the confusion that test train is prepared by the element. And minimum number of reference wagon here. This is actually, if we see as per OIML, 106. The word is total number of wagons in train intended for payment by the railway bridge. Means for general use. Means that will link the property of the railway bridge. If the railway bridge is designed for 80 wagon, that means this is talking about the 80 wagon. N is talking about the 80 wagon, like that. So for example, in your railway bridge, it is designed for 60 wagon. So if N is more than 30, then we have to select 50 reference wagon. We will select 50 reference wagon. After that, consider 5 reference wagon, and by using control instrument, the empty wagon weight is 40 ton, partially filled 60 ton, and fully filled 100 ton. For example, I have taken not 15 reference wagon. I have taken 5 reference wagon. How much? 5. For example, empty wagon weight is 40 ton. And these are partially filled, say partially 60 ton, just example. And fully filled 100 ton, just example. We have to prepare. Then how one can prepare the reference wagon before starting the testing? We have to select, we have to take the control instrument, means non-automatic weighing instrument for preparation of reference wagon, class 3 or class 4, that must be verified. If it is immediately verified, then the provision is given, the maximum permissible error shall not be more than 1/3, and if any time, then shall not be more than 1/5. So on this technical part, because time is not so much permitted, so just I am coming on the focusing point. Coupled static weighing, just example for the reference wagon preparation. Please see. For example, I have to prepare the reference wagon. Wagon number 1, reference wagon identification as per railway department, and 2 Excels are there in the wagon. Have you got the display or not? Word display?
Yes, sir.
Yes. Word display, word. As per railway department, like that is there?
Observation table is not visible. Observation table is not visible.
Oh,
Observation table is not come up.
okay. Let us see. Please, one second. Now is visible? Please, one second.
Sir, your video is not also visible.
My video is also not visible.
Sir, it is in the beginning, first slide. Okay, what we can do, sir? You can take for 5 minutes break and kindly prepare your presentation, ready with the presentation. In the meantime, we can do with Mr. Vesh.
Okay, okay. Thank you, sir.
Vesh sir, you kindly do it.
Let him complete because many of the things are common with him. So let him complete.
Sir, now it is, Dwivedi sir, it is okay now with you?
Oh, yes, sir. Yes.
Can you share?
Yes, sir. Yes, sir. Yes, sir.
Actually, Dwivedi Saab, the presentation is totally in black and white, and they are giving this presentation to the bridges also. So he might be giving the working principle, operation, and so many other things apart from whatever given in the our general rule. So he might be giving the so many others materials also जो है. So his knowledge may be better जो है. Let him express the things जो है, then we'll come to the question जो है. Okay.
Okay, sir. Okay.
Now, sir, it's visible.
Yes, sir. It is visible.
द्विवेदी साहब आप बहुत अच्छा लेक्चर दे रहे हैं, अपना लेक्चर पूरा करिए जो है.
Please, sir, please.
हाँ, आप जो है
Yes. Actually, I would like to share sometimes what happened in the field. So many officers get the prepared reference wagon from the railway department. But if they have to prepare in the field before starting the verification, then how they can prepare the reference wagon? Just I try my best to give an example. For example, a wagon having 2 axles. Then that wagon is carried on the control instrument, means non-automatic weighing instrument. And for example, partial payment is there. So if the first axle payment is 20.002 ton and second is 19.998 ton and total becomes 40 ton. If the indication comes 40 ton, that means I have prepared a wagon of 40 ton and that will be treated as a standard wagon, reference wagon, and that reference wagon we can use for the testing procedure. Similarly, in the same table way, we can prepare another wagon, 60 ton, 100 ton, and the value of the reference wagons will be in such a way that we can comply the weighing range of the railway bridge. Weighing range of the railway bridge. Once the wagons are prepared, then most important duty of the LMO is started to calculate the maximum permissible error. Otherwise, we can't take the decision whether it is within limit or it is beyond limit. So next step is to find out the MPE for that. Calculate the maximum permissible error for reference wagon train as applicable. Just I am coming on that. Please 1 second. MPE, the most important thing, once we have prepared 40 ton reference wagon, then what should be the MPE for the wagon bay? Whether it is an empty wagon or loaded wagon, doesn't matter. We have the concern with the mass. Mass is 40 ton. So for wagon weighing, 3 cases are there. If you see the general rule or OIML recommendations, we will find in the weighing instrument or measuring instrument some direct maximum permissible errors are given. Directly tables are applicable, but somewhere direct values are not, like fuel dispenser. Direct value is not given. We have to calculate the MPE by applying the condition. Similarly, in railway bridge, we must also apply the condition. For wagon weighing, most important core part of the discussion. This is the, after that only the testing, how we have to pass the wagon. But this is the core part always I am giving the more stress for the allowed error. Because this is the key role for the verification. If once it is wrong, then everything becomes wrong. So we have to give more accuracy on that. Here in railway bridge, table is given. What table? For 0.2 accuracy class during the verification plus minus 0.1%. For 0.5 accuracy class railway bridge plus minus 0.25%. For 1 accuracy class railway bridge plus minus 0.5%. For 2 accuracy class railway bridge plus minus 1% at the time of verification. And at the time of inspection, just double. If 0.2 plus minus 0.2%, 0.5 plus minus 0.5 and so on. But this table is not directly applicable. Some conditions are given. So first I am going to discuss conditions of MP calculation for wagon weighing, because we have prepared the reference wagon 40 ton. Similarly, process will be same. But for 40 ton, how we will calculate? Condition 1 is saying, very important, whatever the wagon weight, apply the table based on accuracy class. We have taken accuracy class 2. If you think in the beginning, in the example, accuracy class 2, for the verification, 1%. First condition is saying, calculate the value according to table. Or table is saying, for accuracy class 2, 1% of the reference wagon weight. Reference wagon weight is 40 ton. So 1% of 40 ton, 0.4 ton. First condition. 3 condition I will take. Out of these 3 conditions, the value which is more, that will be the MP for 40 ton. First condition is very easy. Okay, this is a reference wagon 40 ton. And accuracy class is 2 to 1% of 40 ton means 0.4 ton. Rounded to the nearest scale interval. Condition is. Scale interval is 0.2. It is already rounded 0.4. So no need to round it here. Already 0.4. But in maximum cases, I found under the second condition, so many confusion. Because second condition is written, apply the table on a single wagon. Now question comes, what is a single wagon? Single wagon means 35% of maximum wagon. Maximum wagon weight is given. Condition 2 is saying, apply the table on a single wagon. Then what is a single wagon? Single wagon means 35% of maximum wagon weight. And maximum wagon weight is given 100 ton. Then 35% of 100 ton, 35 ton. 35 ton. Then we have to apply the table. Means 1% of 35 ton means how much? 0.35 ton, rounded to 0.4 ton. And case 3 is saying 1D. D is already given. How much? 0.2 ton. So how many values we have find here? 3 values. One is 0.4 ton, another is 0.4 ton, and another is 0.2 ton. Out of these 3 values, which is more? Are equal? 0.4 ton. That means for 40 ton reference wagon, maximum permissible error is plus minus 0.4 ton. When an officer pass the 40 ton reference wagon over the railway bridge, and if the indication come 40.5 ton, 40.5 ton, that is beyond limit. If the indication come 40.8 ton, beyond limit. If the indication come 40.4 ton, within limit. If the indication come 40.2 ton, within limit. If the indication come 40 ton, within limit. Similarly for 60 ton, similarly for 100 ton, similarly for other ton, whatever ton we have considered for the verification. But question comes, if the instrument is designed for train weighing, okay, you have discussed for the wagon weighing, but what about the train weighing? Very easy, in a single step. Very simple. For train weighing, only 1 minute I will take on that to give the concept for the train weighing. In train weighing, totalized weight comes on the indication. Totalized weight. That means for case 1, we are taking a single reference wagon weight. But when I am talking for the train weighing, under case 1, I will take totalized weight of the train. For example, train prepared by the Alamo having 15 reference wagon. Having 15 reference wagon, each of 100 ton, just example, each of 100 ton. Then the total train weight becomes 1500 ton. Under case 1, we will take 1% or whatever the accuracy class depending upon that percentage of that total train. If 15 wagons, each of 100 ton, 1500 ton, then 1% of 1500 ton. Now second case is saying 35% of the maximum wagon weight. 35% of the maximum wagon weight. But here 15 wagons are there, then it should be multiplied by 15, but not. 35% of maximum wagon weight multiplied by 10 reference wagon, not more than 10. So in place of 35 ton, it becomes 350 ton. Then we will apply table. Third condition is given 1D for one wagon. Then a train having 15 reference wagon, no 15D. It is again limited up to the 10D. Up to the 10D. This is the process for the MP calculation for wagon weight and for train weight. Once the MP is calculated, that means we are ready for testing. Because we have prepared the reference wagon, we have cross-checked the marking, and MP is also ready, then our next step is to start the verification. Similarly, I have taken for 60 ton and for 100 ton. There is a repeatability for, so you may go through the same as for 40 ton. Step 7, perform the in-motion test. How we have to test the railway bridge. Everything is ready. Now, as I have prior discussed, railway bridge may have 3 kinds, whether for uncoupled, whether for coupled, whether for train weighing. We can't perform the uncoupled testing if the provision is not there for that railway bridge. If it is not meant for uncoupled, we will not perform uncoupled. If we will not perform coupled, if it is not meant for coupled, we will perform uncoupled or coupled or train weighing for which it is meant. Provision is there, the uncoupled, coupled and train, but we have to check it is meant for train or it is meant for coupled or it is meant for uncoupled or it is meant for coupled and train. Maybe 2 things are there. It is meant for coupled as well as for train. Then both tests we will perform. Just I am taking under consideration if it is meant for coupled wagon way. Coupled wagon way. If it is meant for coupled wagon way. For coupled wagon weighing, as per the rule, as per the OIML, it is given that don't take less than 5 reference wagon. And make a train, empty train. Empty train means no load inside the reference wagon. Whatever the tare weight, we will confirm the tare weight from control instrument. We will make a train of 5 reference wagon. And we will pass. Then we will see, because it is a coupled wagon weighing. In coupled wagon weighing, wagon wise results come. So if the 5 wagons pass over the railway bridge, then 5 reading will come. But not this is enough. We have to yield not less than 60 reading. So 5 wagons are there, then repeatedly we have to pass 12 times. Then 60 readings will be there. Out of 60 reading, no reading should have the error more than the maximum permissible error. What is the standard here? Our reference wagon is the standard and indication is the measured value. The difference between standard and measured value is the error, and that error is compared with the maximum permissible error. That error is compared with the maximum permissible error. So now for coupled wagon weighing, we have to 5 reference wagon minimum. Otherwise, as per the table, but not less than 5. We have to pass 12 times to yield 60 readings. Similarly, that empty reference wagon will be partially filled, and we will repeat the process. Then fully filled, we will repeat the process. Total how many readings becomes? 60 for empty, 60 for partially filled, and 60 for fully filled. Total readings becomes 180 readings. 180 readings. Out of 180 readings, all the readings should come within the MPE, but one clause is given in our general rule. If the railway bridge is initially verified first time, then 10% readings may have the error more than the verification error, but shall not more than the error of inspection.
द्विवेदी जी आपका माइक ऑफ है। द्विवेदी साहब, योर माइक इज ऑफ। I think there is some technical problem at ILM Ranchi. So I think Vaishya Saab, kindly you can take over till the time they again connects.
Mr. Agarwal, it will be again something will be repeated again. So that's why I was thinking let him complete.
Your voice is
Because
not clear, sir.
I think let him complete because many of the things will be repeated again.
Yeah, now it is okay.
So it is much better that he completes it. Otherwise, whatever he has said, I'll be probably repeating them in a concise format. And maybe he's covering up whatever I was also going to say. Maybe certain things will be separate, but I think let him complete. He's come back online. He is on video. Can you hear me?
Yes, sir, we can hear you.
Okay,
Please speak.
okay, fine, fine. So let Mr. Dwivedi complete it, please. That will be much better option.
Hello. Thank you, sir, and sorry for a technical issue. Actually, just I would like to finish my things that after passing the wagons over the railway bridge, we will note down the indications. We will calculate the error. Error means the reference wagon weight value is the standard value, and whatever the indications from the instrument, that is the measured value. The difference between them is the error, and that error we will compare with the maximum permissible error. If all the errors are within the limit, then that will be recommended for the stamping, and finally the railway bridge will be stamped. Thank you, sir.
Thank you very much, Trivedi Saab. Your explanation is very good, and certainly we will take your help again in the due course of time. Today there was some technical problems, and anyway, but it was very good. We understood a lot. Now, Vaishya Saab, kindly you will continue, please.
Yeah, please give me the sharing link. Sharing. Yeah. Yeah. Good afternoon, Mr. Mathur, Mr. Dixit, Mr. Agrawal, and the distinguished guests. I am HK Vash. I am from every India. And Mr. Dwivedi really presented the presentation very nicely, and I hope I am a match to him because many of the things that I'm going to say are probably are going to be repeat of whatever has been covered by him also. So maybe it's a bit repeat or it's a revision basically for you. The topic was testing and verification of automatic railway bridges. So I'll basically stick to that only. A little bit about our company, Every India. Every India has been supplying weighing instruments since 1911 in India, which Mr. Agarwal also kindly said in the beginning address. And we are part of the worldwide group Everywaytronics with manufacturing locations at US, UK, China, Malaysia, as well as in our country, India. And Everywaytronics itself is a part of ITW, a USA company that has got a turnover of 15 US billion. Every India is certified for ISO 9001, ISO 45001 that is safety, and ISO 50001 that is for energy. And we are the leaders in supplying electronic way bridges. Plus, we also supply automatic railway bridges, platform scales, floor scales, system and software solutions in our country. We manufacture OML approved C56 accuracy load cells in our country, in India. And we have got presence all over India with sales and service personnel at about 55 locations in our country. That's a brief about Every India. As Mr. Dwivedi mentioned about weighing instrument and non-automatic weighing instrument and automatic weighing instrument, our topic is automatic railway bridge. Automatic weighing instrument meaning where operator is not required and the weighing is done following a automatic process with a determined program. For example, in-motion railway bridge, belt wear, wayfeeder. On the other hand, wherever an operator is required, say to deposit the load or to note the reading of the load, for example, weigh bridges, platform scales, those are called navis, non-automatic weighing instruments. Just to start, automatic railway bridges. Now, legal requirements for automatic railway bridges are covered under General Rules 2011, Schedule 7, Heading C, and it follows OML R106. As you know, our country has been following standards which have been made by OML, which is an international body which makes standards for most of the measuring instruments, and India is part of that. This is again comes under GATT, so that the standardization of the equipment is there, and there is no barrier in doing trade between the countries. As railways is involved, railway bridges meaning they will be installed on railways lines, and they will be installed using on they will be using the railway stock, and railways procure all their equipment based on their specifications. So RDSO has got a specification for railway bridges. They call it IFWB, in motion way bridges, which is WD 29 Business 19 Region 1. October 2021 was this version released, and this is suitable for less than 15 kilometer per hour speed. Now, since all the customers are going to use the railway stock as well as the railway lines, so they have to deal with the railways. So they also follow this. They procure their equipment as per these specifications. Now, while legal requirements are basically concerned with the meteorological requirements, as Mr. Dwivedi explained quite well, but RDSO requirements also cover the other railways aspects like construction of the machine, how it should be, what the software should be doing, what components should be used, what kind of foundation should be made for the rails, what should be the room dimensions, and room should be made how, what are the AMC requirements and the spare requirements as well. So they take care of the complete equipment apart from metrology. And obviously they say that they will follow all the legal metrology rules. Obviously, one of the requirements being that machine has to be approved, model approved by LM, then only they will use it. And incidentally, there are only 8 manufacturers in our country who are approved by RDSO to supply railway bridges, in motion railway bridges for less than 15 kmph speed, and we are one of them. A general block diagram of a railway bridge. This lamp, track switches, way rail, this all the systems will have. Any railway bridge that you see will have these systems. The lamp basically to give the indication on overspeed and the system is ready. Track switches are put on the rail for two things. One, to find out what kind of vehicle is moving on the track. That is, it is a loco, it is a brake van, or it is a wagon. Because locos and the brake van weight is not to be taken, and they are placed by each manufacturer as per their own locations, and their numbers also vary as per the manufacturer to manufacturer. There could be 4, there could be 8, there could be 10. And a varial, again, a varial, as Mr. Dwivedi explained, gives the signal for each of the axle that comes there. Then there is a control. This console, now this is particularly for every India. This is my design, but other manufacturer design may be different. And then is connected to operator PC, through which he gets all the weights of all the wagons, and he can take the print on the printer. So this is all specified by RDSO. This is all specified by RDSO. All these items have been specified by RDSO, plus a little bit of it is also specified in the legal metrology rules. Just to give an idea of the block diagram, for example, this particular diagram shows the way rail and the junction boxes. 2 junction boxes are shown. Now here one will have all the signals coming from the way rail, and second one will have all the signals coming from the track switches. The track switches will something look like this, or they are the proximity switches, because that is the current specification. And earlier we used to have the mechanical switches where the wheel used to touch the switch arms, and then they used to get actuated. But current specifications ask for the proximity switches. They don't touch. They are the inductive switches. This is a controller. This may be in the shape of a small indicator that you see in a probably in a static Weighbridge, which does everything. Now, this controller takes all the signals from track switches and the weigh rail basically, and gives signal output to the lamp and the hooter also, which is not shown here. So this guy processes all the signals that comes on track switches to determine what kind of wagon it is and the speed of the wagon. The weigh rail signal which comes here, then it is used to determine the weight of the axle which is coming on. Now here you can see a close-up of the rail and the track switches. Now these 6 items that you see are the track switches, and these 2 items here and 2 items on the other side are the basically load cells. Now this is the implementation of every India. Someone else's implementation might be differing something. Now this area normally is between 500 to 600 long, just enough for an axle to be placed and weighed. So Mr. Dy.Dir did explain on full draft weighing and multi-draft weighing. So 99% of the rail Weighbridges are multi-draft. That means all the axles are weighed one by one, and then they are summed up together. And track switch logic tells how many weights have to be weighed. If it is an axle wagon, then 2 axle weights will be summed up together. If it is a bogie wagon, then the 4 axle weights will be summed together. If it's a loco weight, then that will be eliminated. Of course, it will not be shown what is the loco weight onto the printout or on the display, because that is as per the specification. Though the system can weigh them, definitely. Coming straight to the accuracy classes. Oh, sorry. Now, there are 4 accuracy classes, 0.2, 0.5, 1 and 2. During the verification phase, this is the accuracy which is allowed. And during the inspection, that accuracy becomes double of that. I think Mr. Dy.Dir did explain quite well. And these accuracy classes are also related to number of divisions. Number of divisions, that means maximum wagon weight divided by the D. That gives the number of divisions. So maximum division you can have is 5,000. So you can actually calculate by using this value what can be the minimum capacity and the maximum capacity of the wagon weight that can be weighed onto the Weighbridge. Currently, RDSO specified or purchases IMWBs or the rail Weighbridges as per wagon accuracy as per class 1, train accuracy as class 0.5. That means 0.5 for the train accuracy and 1 for the wagon accuracy. And the capacity of the Weighbridge is 140 tons. That means maximum wagon weight it can weigh is 140 tons. So you can see 140 ton cross divided by 200 will come around 700, and so it comes in class 1. It comes in class 1. Mr. Dy.Dir did give an example also very clearly. And what are the errors allowed? This talked of the accuracy errors, but there is more to it. Whenever a wagon is being weighed, one is the value one has to calculate as per the percentage, 1.1%, 0.25, 0.5 or 1%. Then you have to calculate the value as per the 35% of the maximum wagon weight, as mentioned on the descriptive markings. So if it's a 140 ton Weighbridge, then 35% of that will be 49 tons. So what is the error for that? then 1D, which is 200 kg in the case of RDSO current specs. So I've done some, I'll just show you this. If there's a Weighbridge, say 140 ton cross 200 kg, and it is of class 1 accuracy, that means 0.5%. So that means 0.5 meaning 80.3, 0.4, it will give the error of as per accuracy 0.4. For 46.32, it will give 0.23. If I go as per point D, it will be 0.2. If I calculate as per 35%, it will be 0.245. So the maximum error is 0.4. So I will apply this 0.4 error on this my 80.3 reference wagon. So this will become maximum allowed weight will be 80.7 and 79.9. But point is, the indication will come in 200 kg. So 80.7 will never be shown, 79.9 will be shown. So these will be again rounded off to next value 80.8 and 80. So 80.3 wagon will have maximum value of 80.8 and minimum value can have 80, which will be considered as okay. Same thing is for 46.32. 0.23 will be the error, and which is rounded off to 0.2. So my maximum error that will be allowed for this is 46.6 to 46.2. Same thing is for 19.1. Basically what will happen is all the weight wagons above the 35% will be having this error coming up, that is our experience, of course, and below 35% or everywhere the error will be calculated as per this. That will always be the case. And a second case is done here for 100 tons for 100 kg. This used to be earlier specifications, class 1 accuracy. Here 0.5% calculation, 0.402, 0.232 and 0.097. Then as per D, the error will be 0.1, 0.1. And as per 35%, it will be 0.175. So we'll have to see which error is the maximum. So we can see here 0.402 is the maximum, greater of the errors, 0.402 or 0.1 or 0.175. For 46.32 wagon weight, it will be 0.232 or 0.1 or 0.175. So we'll consider as 0.232. And again for 19.3, it will be 0.175. You see, so the moment we got changed, the resolution got changed, accuracy class remaining same, but something did get changed. So resolution plays a very important role in determining what the accuracy or APs will be. So this is done during the initial verification. Later on, during inspection or in service, all wagons must be twice the accuracy percentage. That means then the errors will be these, and there is errors will be considered, MPs will be considered using these values, double the in verification errors. This is for wagon weighing. Train weighing, I think Mr. Dy.Dir was just explaining. So again, same thing. The greater error has to be from these three. Either value is calculated as per accuracy class, rounded to nearest scale interval. Value calculated according to again accuracy class table, but for 35% of maximum wagon weight that can be weighed on the platform, multiplied by number of reference wagons, but not exceeding 10, and rounded to nearest scale interval. So if a train has got only 5 reference wagons, then logically we will only multiply by 5. But if it's got 50 reference wagons, then we'll multiply only by 10. to get this value for the train weighing, and 1D for each wagon of train, but not exceeding 10D. Again, if a train has got 5 reference wagons, then it will be 5D. If it has got 10 reference wagons, then it will be 10D. And if it is 15 reference wagons, then also it will remain 10D. Now, this is how this auto railway bridge train error will look like. He was explaining that if there are 15 reference wagons are there, then 7.5 tons is shown here. 0.5%, 100 ton cross 15 is equal to 7.1. That is the error shown here. 35% rule, 35 ton cross ton, 350 ton. So this is the rule shown here. And it will be 1.75 ton error. So that is what is shown here, 1.75 ton here for 350 ton train weight. And 1D, as per 1D, since my resolution is 0.02 ton, so 0.02 cross 10 is equal to 2 tons. So this is the line which is 2 tons. So at any point you can see if this is the train weight greater the error. So this is the greatest error. So 2-ton error will be allowed there. If this is the weight out here, 1000 ton is the weight, then this is the error which will be allowed. If this is the weight, then this will be the error allowed. So similar graph can be made, or a table can be made for any other class, or any other capacity, or any other reference wagon weights. Because here we assumed the reference wagon weight is 100 tons. It could be 50 tons also. Capacity we assume to be 100 tons. It could be any 120 tons, 140 tons, and number of reference wagons we have to decide. And class of the accuracy also we have to decide. Now that's okay. We calculate the MPs of each of the reference wagons. That is, when the train is being run and wagon gives us a weight, what is the maximum error allowed, that we have calculated. But there is another thing. On initial verification of the railway bridge, 90% of the readings have to be within MPE that you have calculated, and balance 10% can have error double those error, but they cannot exceed that. That means that is the kind of relaxation given. Not all the 100% readings need to be within MPE. 10% can be out, but they cannot be out twice the value that you have calculated, twice the MPEs. So this is calculating the error and the rule. What tests have to be done? If it is an uncoupled wagon weighing, then minimum 5 reference wagons have to be taken, and the weights have to be of the wagon from tier to the full load have to be weighed, and then they have to be calculated as per their MPs, and all of them should pass. If there is a coupled wagon weighing, then you have to actually use a train of empty reference wagons and a test train of fully and partially filled wagons, not having less than 5 and less than 15 reference wagons. So you can have any train which has got not less than 5 and less than 15 reference wagons. It has to be weighed in each direction to yield not less than 60 wagon weights at various speeds. So you got an operating speed of the train. So you have to take the train has to be run in both the directions, and you have to get at least 60 wagon weights, 60 reference wagon weights, 60 reference. So if you got a train of 10 wagons and you got only five reference wagons, then you have to still run the train 12 times in each direction. So that means 12 times in one direction and 12 times in the second direction. Now here, though our legal metrology doesn't specify really, but RDSO specifies these tests have to be done only in pull mode only. Reason being very simple. It has been seen by experience. Pushing meaning that those buffers and the couplers, they create undue pressure on the wagons and they create problems in the readings. But when it is pulled, then all those buffers and the couplers are pulled totally, and whatever the effect comes, that can be taken care during the setting up of the instrument. But in the case of push, that is uncertain quantity, very uncertain quantity, and that cannot be taken care. So all those tests as per in Indian conditions have to be done in pull mode, and you have to get 60 wagon weights. Now, obviously, he was explaining this table, Mr. Dwivedi. If there's a train of less than 10 wagons, then all the wagons have to be reference wagons. If you are using a train up to 30 wagons, 10 to 30 wagons, then at least 10 reference wagons have to be there. And if your train happens to be 30 or more wagons, then there have to be 15 wagons. So if you're running a train, test train is having uh, uh, say 30 wagons, and it should have 15 reference wagons, that the train has to be run at least 4 times in each direction to get 60 wagon weights for each direction. And obviously, as I explained, once you get the results, 90% of wagon weight should be within, and balance 10% should not exceed twice the accuracy class percentage. Now, Mr. Dwivedi did spend a lot of time on the control instrument, but in our India case, it is in each of the zone, railways provide us the test train, normally consisting of 5 or 6 wagons, reference wagons, which is a test train, and that train is a calibrated train. That means it has been stamped by, it has been weighed on some control instrument somewhere, on a class 3 instrument somewhere, and it has been stamped by the weighing inspectors. So the reference wagons weights are known to us. So that train is provided by the railways in all the cases. I have never seen a single case where a control instrument had to be used to make a wagon in the field, because wagons, if you have a wagon with you, it costs money. Railways charge you for that. So time to, and it's with the very small amount of 500 600 space available, it's very difficult to place the axle accurately onto the weigh zone and get an accurate result, even if the instrument can be used the way it is being constructed today and supplied today to be used as control instrument in our country. Now, this is a actual sample report of a site. This is an inspection report. So you can see that these are the wagon weights, which are known wagon weights given. They calculated the 1%, since this was inspection being done, so they applied 1% rule, because the accuracy class is for the wagon is 1. So the tolerance is 0.5 and double of that 1% during inspection, and then they run the train 1, 2, 3, 4, 5, 6, 7, 8, 12 times, and they got all the weights. Then they summed all the rake values, and ultimately they gave total readings obtained 60. Readings within 1% variation were 60. That means all were 100% were passed. And then same thing for the rake also. The rake accuracy achieved was so and so. So this was in one direction and this was in second direction. And the report was signed by obviously our people plus railways people. And many times this report is also signed by the weighing inspector also, because getting a test train from railways and using it on a IMWB for 2 or 3 days is a costly affair. It costs money. The customer has to pay to the railways for keeping the test train and the loco. So this was the testing part. In train weighing, what happens now? Since you have already done so many of reference wagon weights you have already got, and you run the train already 24 times. So what you need to do is, without repeating the test, the weight of reference wagon shall be summed, and any error shall not exceed the MPB as per the given accuracy class applied to the summation. So that means all the reference weights can be summed up together, and then the MPE can be applied as per the accuracy class. So if it is 1%, then it will be 0.5% weight. It should be within 0.5% accuracy. It should be. RDSO specifies for train weighing accuracy class 0.5. Now, here they got a stricter rule than the legal metrology. Here also they say that 90% of total trains should be within plus minus 0.25%, called class 5 as per, of the known weight of the train, and not more than 10% of the total train shall exceed 0.25% and lie between 0.5%. So same rule which was for valid for the wagons, which is given in the legal metrology, has been applied here here for the rake accuracy also. So here they are checking all of these wagon weights, individual weights which have been received. Each of these individual wagon weights received, whether they are falling within 0.25% or not, and 90% of them should be falling within 0.25%, and 10% can fall within 0.5%. Now I'll just take a hypothetical case. How does it? This I have taken a hypothetical case. Train runs 100 tons, reference wagon weight are there, and there are 1, 2, 3, 4, 5, 6 weights are there, and I have done 10 runs of that. You can see all the weights wagon wise are absolutely correct, 100%. All the wagon weights are within class 1 as per RDSO, but here the train accuracy is out as per RDSO, but this is okay. This is 90%, so this is fine. And as per LM, the train is okay because the weight was 5996 and allowed is between 5885 and 6015. Case 2.
Sir, I'm sorry, we are not able to see the case. It is just showing the first slide.
Oh, I'm sorry. I'm sorry, then I'll share the screen. I'm sorry. The previous slide you could see?
Yes, sir. Yes, sir.
Okay, just a minute. I'll just. Are you able to see now?
Please change it, change.
No, sir.
No, just a minute.
No, it's not visible.
Okay, just a minute. Just a minute.
Actually, you have to share that slide which you want to show if you are.
No, previously I opened it, got shared. I don't know why this one not getting sharing.
Okay,
The
no
previous
problem.
one wagon was shared. I don't know why this is not getting shared. Just a
No
minute.
problem. No problem. Please continue, sir.
I'll just show it after this. Okay, the effect of that.
Okay, please continue.
I'll just after show it. Let me see shared stop. Okay. Here.
Now,
Yes, sir. Now it is okay.
now it's okay.
Okay, fine. So case 1, I've taken train runs. I've taken 6 wagons of 100 reference weights, and I have just, these are hypothetical cases. So here you can see all the wagons are 100% or within 0.5%. So wagon is 100%. My one rake as per legal metrology also is okay because my sum of all the reference wagons is 5996 and they should be between 5985 and 6015. So is okay as per LM. But as per RDSO, this rake reading is not correct. So but it is okay because it is still within 10%. 90% are still okay, but 10% are not okay. Second case, again the same case, my wagons are all 100%, absolutely fine. Train as per RDSO is failed 0%. As per legal metrology is okay because this weight of all the wagon, all reference wagon weight is coming to 6,000. 600 costs 10 train 6,000. So my train LM is okay. But so this result will be will be rejected by RDSO. Whereas you see such a beautiful results, and this can happen in any system. Just a minute. So this was about the train weighing and the little difference that RDSO has got with respect to legal metrology. In fact, RDSO specification much more harsh, and he's a customer, and so we have to obviously listen to him. And it's not a it's not against legal metrology because it's a more harder specification as compared to legal metrology. Apart from that, he spent quite a lot of time, Mr. Dwivedi. I have just listed down. During verification and inspection, these metrological requirements have to be checked. Accuracy class of the equipment, maximum permissible errors, what are allowed, what is the scale interval, minimum capacity, whether it's greater than equal to 1 ton and less than and greater than minimum wagon weight divided by number of partial weighings. Minimum wagon weight is specified is greater than 50 D. Single axle bogie weights are not getting printed, and if they are getting printed, they are printed with a warning that they cannot be verified. Display, whatever it shows, is same thing is being printed on the printer also. If is to be used as a control instrument, then it has to perform as per class 3 non-automatic weighing instruments legal metrology rules. Wagon weighing has to be performed, and train weighing, which I discussed in the beginning only. Then technical requirements also he has to see, the LMO has to see composition, load receptors. I showed weigh rails, apron. I think Mr. Dwivedi discussed it, the portion just before the weigh rails. Vehicle identification devices, track switches we talked of, indicating devices, the display we showed in front, printer, and the control unit. I showed the complete console. Suitability of use, vehicle, site, method of operation for which intended. So for whatever use that railway bridge has been put, or whatever wagons are coming there or locos are coming there, the equipment is able to identify and take the weights of them. And very specific, not to weigh liquids unless until compensated. These IMWBs are basically because axle weighing devices. So if wagons are carrying liquids, unless until there is a compensation mechanism, they should not be weighed for weighing liquids or wherever the center of gravity of the wagon is going to shift when it is moving. Then he has to also look for security of adjustment, whether all the adjustments that can give a long result are secure. Any maladjustment which is possible, and any interlocks are present which can stop the process of weighing. Uncoupled weighing, if the equipment is for uncoupled weighing, then it has to recognize and indicate if two coupled wagons are or two nearby wagons pass. Two nearby wagons meaning that it should not happen that one wagon gets weighed with another wagon. One wheel of wagon gets weighed with the second wagon. So it should recognize that. Operating speed, it is not to print the overspeed weights. So any wagon which goes through overspeed, then it is not to print the weight. Totals can be printed in the print with the indication that total weight is not okay. Rollback, in case while weighing the train rolls back, then the axles that have been weighed previously are not to be reweighed. That means the previous results will not change at all. And if this happens during testing, then that weighing will be aborted and a new weighing will be done. Drainage, in case if it's installed in a pit, then drainage is there or not there. Now RDSO as per specifies only pitless, so there are no pit mounted IMWBs as per RDSO, or they will not approve it. Descriptive markings and verification marks. Descriptive markings, Mr. Dwivedi covered quite a bit: maximum capacity, minimum capacity, wagon weight, operating speed, partial wing, full wing, so many things are there. And verification marks. So these are all come under technical requirements, which again has to be checked, verified during verification as well as inspection. Any other difference with respect to RDSO? The legal metrology specifies a minimum 500-meter rail track length shall be available with a gradient of not more than 1:400 on either side of automatic railway bridge. RDSO specifies 100-meter straight rail track with a gradient not 1:400. Now, regarding this, I don't know, Mr. Dixit will be able to throw better light because in a railway board meeting, it was decided that railways will perform such tests and they will send those tests to legal metrology, and legal metrology department will change this specification. I don't know what happened after that, but as of now, this is the difference with respect to RDSO. So there was a time when inspectors, because of this reason, were not stamping some of the Weighbridges, but I think they have been told not to look into this, and only for this reason, don't stop the stamping process at least. I think that's all. Thank you for your patience. I had to repeat number of things which was Dwivedi said, but the topic was like that. I couldn't leave anything out. Thank you so much. Thank
Thank
you.
you very much, sir. Thank you very much. Sir, first of all, I would like to thank for your brief and very interesting presentation in which you have explained how you are doing and how you are taking the observations. As far as this RDSO and the legal methodology differences were concerned, we have already done that, and we have done away that requirement which was available in the general rules. Now it is exactly as per the requirements of RDSO.
But there is no circular. There is no circular, Mr. Agarwal.
There is an amendment in the rules long back
Achha.
in 2011, 21. I
Okay.
will share a copy of that. It is
Okay.
available
Okay.
on the website
Okay.
also.
Okay. Fine.
Not
Fine.
the circular, it is amendment in the rules.
Okay.
And
Okay.
yeah, and as far as no, kindly let me know what standard RDSO is following, because as far as we people are concerned, as I am the member of this OML committee and all, what
RDSO refers to legal metrology rules only. They write that legal metrology rules will be followed.
that is okay, but you say now that there is some stringent
The rate accuracy.
yeah,
That's not a standard either. That's a standard of OML. I don't know how they made that standard, but they have made it. And I have talked to them, but they never agreed to change
okay.
it.
Okay, no problem. And secondly, sir, as far as legal methodology is concerned, we never allow that only 10% or 90% is allowed. 90% it should be correct, or 10% maybe here and there. The legal methodology asks 100% correct. 100% observations should be correct within the tolerance limit as per
No,
the.
it is as per legal metrology rules only.
Okay, okay, we will discuss it again in person. But as far as I feel that it is the same. So
No, no, no.
with this, I think we have done a lot of exercise today with a lot of experts, and Mathur sir,
So,
Dikshit sir.
Ashutosh, I think Mr. Vash has got a point. If RDSO has got some standards, or we need to probably consult and have a meeting with them. And maybe if they are compelling, standards because of the track conditions and the wagon conditions, they are likely to affect them substantially. Therefore, RDSO must have come around with maybe a different or a better standard. That is one part of it. The second is internationally, what the legal metrology is saying about the rakes and the entire train load calculation, and what kind of inaccuracies need to be followed, and why has RDSO come out with this standard? If they are similar, then certainly our amendment, and we need to possibly accept this particular thing, because it is invariably affecting the railway infrastructure, and should be looked into. So we should have a meeting with them and confirm this particular thing.
Right, sir. Thank you. We will do the same, sir. Thank you very much, sir. And with this, I think that a lot of explanations have been made. And again, we will do it in future with some other manufacturers, some other experts internationally and the nationally. Next meeting on this railway bridges very soon we will be having with some international experts how they are doing. With this, I would like to thank Mathur sir, Dikshit sir, Konar Sahab, Dwivedi Sahab, and Vaishya Sahab, and the NIC team who has made this whole program successful. With this, thank you very much, sir. Thank you all. Thank you.
Thank you. Thank you.
Thank you.